we are given coordinate 2, 3, meaning that our x is this, our y. Our x1 is this, our y1 is this. So in that situation, y minus y1, what is y1? 3 over x minus x1. What's our x1? 2 equals to minus m, which is what? Minus 1. So in this situation, we'll be able to get to this level, then we can now cross multiply. So by cross multiplying and looking at our equation, also to find the equation of the line. So automatically we can cross multiply this such that we have 1 times this y minus 3 equals to minus 1 into x minus 2. So we have this y minus 3 will now be minus x plus 2. Then let's transfer this to this one and transfer this. Then we have y plus x equals to 2 plus 3. Then we can now have x plus y equals to 5. So therefore, our answer will definitely be x plus y equals to 5. Sorry, x plus y equals to 5, and that will be no other option than option C. Then the next question, that's question 13. Find the distance between the point Q 4,3 and the point common to the lines 2x minus y equals to 4 and x plus y equals to 2. So in this situation, we've been given a particular point, that's question 13, Q to be equals to 4,3. So in that situation, we have that point already, where that means our x1 is 4, our y1 is 3. Now, the formula for calculating the distance between 2 points, the formula is equals to square root of x1 minus x2, or let's say x2 minus x1 all squared plus y2 minus y1 all squared. This is the formula for calculating distance between 2 points. Now, we have our x1 and y1, so we need to use the 2 other equations to figure out our x2, y2. By so doing, we know that we are given at the point common to the lines, this and this. So we know that we have 2x minus y equals to 4, and we also have x plus y equals to 2. What we need to do here is use the equation of the line y equals to mx plus c. So let's make our y the solid formula. So in this situation, by the time we make our y the solid formula, we transfer this onto this side, and we have 2x minus 4 equals to y. So let's call this equation 1. Then here too, let's make y the solid formula. We have y to be equals to minus x plus 2. Let's call this equation 2. Since we have our y to be equals to this and our y to be equals to this, then we can see that we can extrapolate that 2x minus 4 is definitely equals to what? Minus x plus 2. Since y is this and that same y is equals to this, we can equate them. So by equating them, then we can now have 2x plus x, 2 plus 4. Then we have 3x equals to 6. Then we are looking for x. Divide both sides by 3. By dividing both sides by 3 now, I'll have my x to be equals to 2. So I've been able to get point x. Now, point y. I can use any one of the 2 equations. For convenience, let me use equation 2. So which I have y equals to minus x plus 2. Then I can say x is what? 2. So x will now be minus 2 plus 2. Minus 2 plus 2 is 0. Y equals to 0. So I've gotten the second coordinate. So the second coordinate, they call this one. This one is already q 4, 3. Then I can call the second coordinate, let's say p, which will now be, what is my x2? My x2 here is 2, 0. So this is what I have. So having gotten the second point, then I can now go ahead to solve for the distance between the 2 points using this formula. This is x1, y1. This is x2, y2. So I now have distance between the points. Distance will now be equals to x2. What is my x2? 2 minus x1. What's my x1? 4 all squared plus y2. What's my y2? 0 minus y1, 3 all squared. Now I now have 2 minus 4, that's minus 2 squared, affected by square root, plus 0 minus 3 squared. So I have minus 2 squared is 4, plus minus 3 squared is 9. So I have 4 plus 9, that's 13. So I have square root of 13 as my distance between the 2 points. So I go to my option and see the one that correlates with that, and that would be no other option than option D. Then the next question, find the tangent of the acute angle between the lines 2x plus y equals to 3 and 3x minus 2y equals to 5. We know that if you are to calculate the tangent of an acute angle, we have got no other formula rather than to resort to the use of a formula known as tan theta equals to m1 minus m2 over 1 plus m1 m2. Remember this formula anytime you are asked to solve questions of this kind. So in this situation, what it means is that we calculate our m1 for the first equation, we calculate our m2 for the second equation. Remember that the equation of a line is y equals to mx plus c. So in that situation, this is our gradient, y this is our intercept, but we are interested in our gradient since we have m1, m2. So for the first equation, which is 2x plus y equals to 2x plus y equals to 3, then I can calculate my gradient here. And if I want to calculate my gradient, I will just make y the solid formula. By making y the solid formula, we have y to be equal to, this one will come to the other side, that is minus 2x plus 3. So if I compare this with this, my equation of a line, I will discover that my m, so it's like saying mx equals to minus 2x. So x can cancel x, so my m equals to, that's my m1 equals to minus 2. I will also do the same for the equation, the second equation, which is 3x minus 2y equals to 5. But this time around, let me transfer my y to the other side, and I will have 3x minus 5 equals to 2y. Now, 3x minus 5 equals to 2y. Now, I am trying to conform this to this equation, y equals to mx plus c. So in that situation, if I revert this now to be 2y, will now be equals to 3x minus 5. So what I need to do now is to divide through by 2. If I divide this by 2, I will have y. If I divide this one by 2, I will have 3 over 2x. Divide this one by 2, I have minus 5 over 2. So in that situation, I can now say that in this situation, to compare this with my equation of the line, I will realize that my m2, or this is my m2 now for the second equation, my m2 will be 3 over 2. And I can now go back to my original formula, which says tan theta equals to m1. What is my m1? My m1 here is, what did I calculate? That's minus 2 minus m2, 3 over 2, over 1 plus m1, that's minus 2 times m2, that is 3 over 2. So 2 here, 1, 2 here, 1. So I have this one. If I simplify this, I have minus 2 minus 3 over 2. Let me simplify this. I have 2 as my LCM. 1 in 2 times this minus 4, minus 2 in this 1 times this minus 3. That's minus 7 over 2. So the numerator is minus 7. So I can write tan theta to be equals to minus 7 over 2 over, then I will have this one as, remember that this is minus 3. If I have 1 minus 3, that will now give me minus 7 over 2 divided by minus 2. So that is minus 7 over 2 times 1 over minus 2. So this one will give me minus 7 times 1, that's minus 7. 2 times minus 2, that's minus 4. So this minus can cancel this minus, I have 7 over 4. So my answer here will be 7 over 4, which is definitely option C here. Then the last one, if line P equals to 5x plus 3 is parallel to the line P equals to WX plus 5, find the value of the W. In this situation, when two lines are parallel, looking at this particular question, we don't really need any rigorous calculation because we've been given the first line to be P equals to what? 5x plus 3. Then we give the second one to be equals to WX plus 5. So in this situation, if you are looking for our, since it has been given to us that the lines are parallel, when two lines are parallel, that means they are, it means that when two lines are parallel, let's say y equals to mx1 plus c, then we also have y equals to m2x plus c. If these two lines, this is the first line and this is the second line. If these two lines are parallel, that means m1 must be definitely equals to what? m2. In this regard, it means that, look at this, x is x here. That means our w is equals to 5. So we don't need to do any calculation here. It's just to apply the principle and our answer will appear naturally. So in that regard, our answer to question 15 is option D.